Swayam Prabha. Digital India. Educated India.
Good morning everybody. In vacuum technology process applications, today we will be covering the first lecture of first module. The module 1, which deals with introduction, basic concepts and applications, is subdivided into 4 to 5 lectures, and in today's lecture we will introduce you the basic definitions of vacuum and how we find the vacuum conditions around us. The concepts covered in this lecture are introduction to the course contents, what is vacuum, in general what is the composition of dry air around us and how it gets modified under vacuum conditions, which is really responsible for various applications, because controlled atmosphere is the background for various high tech applications. And we also deal with little idea of natural vacuum that is there around us. You may say, why we are doing it? Because unless we get a feel of vacuum around us, we feel it is a new subject, but it is not new subject. That is the reason before we go into process applications, we also give you a feel of natural vacuum. Well, coming to the contents of the course, it is a broad spectrum of applications and the backing vacuum technology aspects, and to that vacuum technology the backing scientific concepts, all these things will be covered in a step by step. So, initially we will give you a lucid introduction to the concepts, then it will be followed by production of vacuum, design of vacuum systems, measurement of vacuum, how do you apply it for various applications, and how do you troubleshoot it if something goes wrong, and how do you link it to the quality of the output that you get from these vacuum systems, whether it is solar cell, whether it is a cell phone, whether it is a TV, whether it is any display system or a computer or a manufacturing of IC chip or metallurgical furnaces for making different alloys or distillation and drying of operations involved in chemical industries and pharmaceutical industries. These things will be covered in a conceptual way. More details you can find in respective disciplines anyway. Similarly, we will also cover concepts involved in application of vacuum to electrical industries like high current interrupters, impregnation of high voltage transformers, like that. And in electronics also we have different roles of vacuum at different stages of manufacturing, whether it is a pure semiconductor material manufacturing or based on semiconductors device manufacturing. These things will be covered in detail in the applications. Nowadays you may be hearing a lot of pollution control, water treatment, wastewater utilization, drinking water scarcity, all these things. So, here vacuum technology is going to offer unique solutions. So, in addition to pharmaceutical and chemical, we will also deal with quite a good amount of water treatment and drinking water production from sea water. Then when you go to mechanical aspect of it, you can precisely lift a component or any sub-component in electronic industry using vacuum clutches, or you can transport from one place to the other in an industry using vacuum lift. So, all these things will be covered from mechanical point of view. Of course, you all know that vacuum brakes utilizing pressure difference concepts, the force due to pressure difference concepts are used in a multiply connected train. Unlike a rigid body like car which is stopped by a hydraulic brake, you cannot do that. You have to use either vacuum or pneumatic brakes. Because of relative motion you have to give some leverage. So, you have to use either vacuum brakes or pneumatic brakes. So, that concept from mechanical point of view also we will be covering. But apart from all these scientific, chemical, pharmaceutical, food processing and other applications, two major applications are in space and nuclear sectors. They will also be covered in this course for nuclear fission, nuclear fusion and thermovac chambers, space simulation for satellite testing, etc. So, in a friendly manner I can tell you, if you take satellite, all the electronic circuits are based on semiconductors and other optoelectronic circuits. Most of them are manufactured using vacuum conditions, and as a whole the satellite is tested under vacuum conditions, and the space shuttle that takes the satellite, that is also going 99% of its journey to keep the satellite in the geostationary orbital under vacuum conditions. Unless we simulate it on earth, we cannot stand satellite. Similarly, nuclear fusion, that is to create sun on earth using millions of degrees of centigrade of plasma, confining the plasma, etc. You require ultra high vacuum. If you do not do that, these high tech products will never come up. But several countries are involved in nuclear fusion now to make several small suns rather in various places. That way we will have an enormous source of energy, not picking up from the solar energy, sun himself will come to the earth. So, for such high tech applications you require vacuum. So, in a broad sense, vacuum technology goes to the most complicated VLSI circuit based chip design to the most day to day life used potato chips manufacturing. So, a whole lot of process technologies are involved utilizing vacuum technology. This course introduces all these applications in addition to the basics of vacuum technology, production of vacuum technology, measurement of vacuum technology, and how do you apply these systems or vacuum subsystems to make various applications. So, you will become manpower, those who understand these things, you become a manpower or powerful men and women to handle the high tech vacuum technology in various upcoming industrial sectors. I am not going to read these materials, you can just go through it. So, coming to the definition, what is vacuum? Sir, you are talking vacuum, why we have to do it? Cleanliness or low molecular density or a force concept or a drying concept or a distillation concept or oxidation reduction concept, which concept? These things will be discussed in principles and their applications little later, but much before that some elementary understanding of vacuum, its definitions and vacuum around us will give you a feel of vacuum. That is why the first lecture is dedicated to a school level teaching, and some of it has been covered in your 11th class, 12th class subjects, but that time you have read without much of feeling. Now, we will give more scientific basis to that. For example, ideal gas. Ideal gas is, when is it ideal? Only under very low pressures. So, vacuum conditions are ideal for studying ideal gas behavior, PV is equal to nRT. At higher pressures, it is not allowed. Most of the engineering thermodynamics deals with high pressures, etc., but their ideal gas equations are suitably modified using various correction factors, but here ideal gas is ideally valid, PV is equal to nRT is highly valid here. So, look at this figure. At atmospheric pressure, you have a lot of molecules in a small volume. I have taken unit volume, so that I can say molecular density. When you evacuate this chamber, a unit volume chamber, to a higher level of vacuum, vacuum high means pressure low. You should always be remembering this fundamental aspect. At low pressures or high vacuum, the number of molecules in the space in the same volume go down heavily, and it is this less number of molecules is the basis for electronic industry, basis for space technology, basis for nuclear industry, and along with this molecular density going down, lot of things happen. First thing that happens is the fluid mechanics concepts are out here, because here huge number of molecules with gaps are very narrow gaps between them. It will behave like a gas, an ensemble of molecules. So, all the fluid mechanic concepts like viscosity, Navier-Stokes equations, they are all valid, but when it comes to high vacuum conditions, these concepts are not valid. That means, you cannot use computational fluid dynamics for high vacuum applications. You have to introduce a new dimension called molecular fluid dynamics, MFD type, not CFD. These things will come to in detail later. So, basically a space in which the density of gas is less compared to what is normal around us at atmospheric conditions is said to be under vacuum condition. So, somebody asks what is vacuum, you should say subatmospheric pressure conditions, but light subatmospheric where gas behavior is still continued, they are also popular applications of vacuum like chemical and pharmaceutical, etc., where still the force due to pressure differences are there because of viscous drag, etc. So, molecular distillation and other as drying aspects, boiling point reduction with vacuum, they are there, but higher level it is a molecular concept. So, it is the less number of molecules which will not interfere with hot silicon. Otherwise, silicon processing, when you do, it is a semiconductor processing. If you oxidize it, it will become silicon dioxide, which is an insulator. So, you cannot obviously process silicon to make various semiconducting devices which are required for modern day solid state electronic circuits, unless you process them under vacuum conditions. So, this has to go into your mind. That time we are talking about molecular level. Similarly, bulb, if you keep it without that outside bulb, only filament through which you pass current and you try to get light, no, after some time it becomes red hot in few seconds, it will fuse because it gets oxidized and it gets cut, and unless you go to very high temperatures, you will not get conversion of thermal energy into light energy. That is the principle of incandescent light. We will see later when we go through history of vacuum technology in the coming lectures. Here I want you to get a concept of vacuum. Originally it started in Latin language, vacuum means emptiness, but there is nothing called emptiness. Even under perfect vacuum conditions on earth, which are required for space and nuclear technologies and electronic technologies, we still have 30,000 molecules per unit volume. So, there is nothing called empty. It is very difficult to empty a chamber, because when you try to empty all the molecules inside, the solid walls themselves will desorb to create molecules. is it not? So, you cannot make perfect emptiness. It is somewhat like in philosophy, you cannot make a brain without any thought, it is very difficult. So, emptying brain without any thought is as difficult as emptying a chamber totally without molecules. That is philosophy, but these type of vacuum conditions are ideally required for various high tech applications. If there was no vacuum technology, there would not have been X-ray tube for our medical application, there would not have been semiconductor industry to make cell phones or mobiles or TVs or computers, there cannot be high tech metallurgical applications to make artificial knee bones etc., alloys, melting and casting. There cannot be high quality drugs, because very high tech drugs for cancer and other applications require low temperature processing, because they are long chain molecules. If you try to operate them at high temperature for either distillation or making the intermediates in drying mode etc., they will crack, and cracked long chain molecule will become poison instead of a drug. So, vacuum technology is very important in all these applications. I am little trying to deviate from the point from the basic concept, because here itself you must get a feel of importance of vacuum, and molecular level we have to talk. So, every time in this period, in this series of lectures, what I will be covering is the science, technology, application, product, and finally troubleshooting. So, coming back to this slide, a scientific definition has to be given, not just emptiness, molecules are less, you say it is vacuum. No, American Vacuum Society has given a scientific definition for unit volume, that means 1 centimeter by 1 centimeter by 1 centimeter dice type of volume. If it contains less than 2.5 into 10 to the power of 19 molecules, then it is said to be under vacuum conditions. Okay. This is a scientific definition. How it comes and all you can derive it, lack of time I will not be talking. You can, for hints I can say, you can take molar volume and it will contain that many molecules from given by Avogadro, and you can say 22.4 liters is the molar volume for any gas, and take all those things, you will get this value very easily. Okay. Anyway, how do you measure this vacuum? Good vacuum, better vacuum or best vacuum? Anything less than atmosphere we are telling vacuum, but how good it is? Even if you remove 99.99% of the molecules mass wise from a atmospheric pressure in a ensemble closed end chamber, you still do not have most modern technologies like electronics and space technology and nuclear and metallurgy. See, only after removing 99.99% of the gas from atmosphere, all the modern technologies start. Up to 99%, you will have force concepts like mechanical applications, chemical applications like distillation, drying, etc. Okay, or lifting, precise lifting, etc. So, this is very important for us to get a knowledge of units of vacuum. Here I can tell 1 atmosphere that is there around us is equal to 760 millimeter of mercury. That means, if you take a U-tube manometer, one side perfect vacuum, one side atmosphere, then there will be level difference of 76 centimeters, that is 760 millimeter of mercury. That means, atmosphere is forcing on the U-tube. So, that how it was originally defined as 760 millimeter of mercury, and 1 millimeter of mercury is called 1 torr, named after a famous scientist Torricelli, who did lots of experiments on that. That we will see later in the history. It is also same as 1 bar, but actually to be precise 1.013 bar, and that is 1013 millibar. It is also same as 0.1 megapascal, and in terms of force per unit area, when they one side vacuum, other side atmosphere, the force will be on every square centimeter 1.03 kg is sitting. Like that you can get a feel of various unit systems for 1 atmosphere. In the actual technology, vacuum technology, this will be explained in terms of powers. That means, 760 torr, 100 torr, 10 torr, 1 torr, Afterwards what will you do? You will not tell 0.1, 0.01, you will say 10 power minus 1, 10 power minus 2, 10 power minus 3 torr. Most popular units are torr and millibar. There are lots of industries who are manufacturing pumps and gauges relevant to this vacuum technology, both in abroad as well as in India. There are lots of companies. I will try to introduce when it comes to other lectures. Just on the lighter side, vacuum is new to us? No. Human beings are creating continuously vacuum, otherwise we will die. If we do not create a subatmospheric pressure of 740 torr, 760 torr being the outside atmosphere, that 20 torr vacuum we are creating, then only air goes in. And for it to happen, you have a natural vacuum pump here in the lungs. Lungs expand for the same number of molecules, P v is equal to nRT, n is same. When V expands, P comes down, and we try to expand that much percentage only. A healthy person can expand little more, the person who does yoga etc., he can expand more, he may create 720 torr. So, but whatever it is, and when you stop creating this 720 torr, 730 torr or 740 torr, which normally happens nowadays in corona patients, they are unable to expand the basic lungs, which are natural vacuum pumps which are there in all of us. If you are unable to expand, suction is not there through the nose. So, we cannot breathe, that is why people die. So, if you can breathe properly with better and better vacuum inside using our lungs, we are better off. This is what I want you to keep in mind. Similarly, when you are sucking cool drink, you are trying to create in mouth a good vacuum. Unless you create vacuum, the water or cool drink will not go up against the gravity. So, we are without our knowledge creating vacuum in our mouth for drinking purpose. So, for breathing, which is our life, and for drinking, which is also our life, we require vacuum conditions, which we are doing day to day life without knowledge, without really in scientific or technical knowledge, we are doing it. So, we know vacuum ever since we are born, because we drink against gravity using a straw. Old people, there what happens, teeth are gone, they cannot keep the lips tight, they cannot create vacuum inside mouth. So, what they do, they take a glass and they try to use gravity to drink the same thing. Apparently, it looks very funny, but you can understand reason is they are unable to create vacuum inside the mouth. So, they are unable to siphon, they are unable to lift the cool drink. Okay. In an animal called octopus, it has got better lip tightness, better sealing mechanism. So, it can create 0.1 torr. If only these octopus animals can live on the earth without water, most of the vacuum pump manufacturers will be in trouble, because we can create them and ask them to evacuate our chambers to a level of 0.1 torr, which will create lot of applications in chemical and pharmaceutical. Anyway, that is in the lighter side. There are various pumps which are very strong and rugged, and lot of companies are involved in manufacturing rotary pump, screw pump, various types of pumps like roots blower to produce this 0.1 torr, but it is naturally available around us. So, in this slide you get a feel of natural vacuum, molecular density variation as pressure goes down, and how much level of vacuum we have to create in our day to day life in sucking as well as breathing, and popular units that are being used in the world on vacuum technology, which is very important technology for most modern industries. So, what is the composition of air at different pressures? I need not discuss it elaborately, because most of you know in the school level. It contains 78% nitrogen, 20% oxygen, argon is third price goes to 1%, 0.93 let us say, then rest of the gases. This is what we think. A dry air composition at 760 torr at sea level at 0 degree centigrade contains this composition, whereas in terms of partial pressures, total pressure being 760 torr, you can convert them, and in terms of torr you can create this. This you can do it as an exercise, I leave it to you because this is a school stuff. But one thing important is, in reality this is not the composition. There will be various levels of moisture at various timings. A rainy day it will have a lot of water vapor. In a dry day there may not be water vapor at all. So, on an average, even in normal day to day life, we may have 2.5% of this by water. So, how do we account that in here? Accordingly, the 2.5% has to be shared by reducing the percentage by other gases. So, we have to do the suitable modification, but it is customary to say composition of air is 78% nitrogen, oxygen, etc., because we consider it in a scientific manner in a dry chamber where moisture is not there. Of course, vacuum also helps us to get dry things, but you will be surprised when you start evacuating, initially 78% nitrogen or oxygen, etc., but actually as soon as you start evacuating, percentage of all these gases will come down, but water vapor is not coming out easily because of various limitations are associated with the pumps also, we will see later. So, that way you will suddenly find water vapor concentration is very high. So, this composition of dry air at different pressures is also very important. In fact, most of the water is there in all surfaces exposed to atmospheric pressure in the chamber. So, only under evacuation these things will start coming inside the chamber. That is why we have to be very careful in dealing with water vapor in evacuation. This we will see in the production of vacuum little later in detail. So, in coming to the natural vacuum, in continuation of that, up to 100 kilometers height, that is called ionosphere or troposphere, pressure decreases slowly by a factor of 10 for each 15 kilometer of altitude. That means, around 90 kilometers from earth's surface, you have already 10 power minus 3 torr in an infinite volume almost. That is the power of nature. And beyond 100 to 400 kilometers altitude, pressure decreases because there is nothing much to decrease, already it is 10 power minus 3 torr. It decreases relatively slower, and at 1000 kilometers, which is nothing in astronomical distances, even our geostationary satellite is much beyond this. Okay? And this is a standard 11th class question, what is the height at which a satellite is stationary with respect to the rotation. So, I leave it to you to get an exercise at geostationary satellite distance, what will be the vacuum level. That means, our poor satellite which is giving us, helping us in getting telephone communication, etc., and internet, it is surrounded by ultra high vacuum in infinite space, I am telling you. So, it is travelling years together in a geostationary manner under ultra high vacuum conditions. Unless we simulate it under vacuum technology, we cannot put this in the satellite in the proper orbit. So, vacuum technology that way is very important, but here I am talking vacuum in nature, but there I will be talking the necessity of vacuum to simulate the nature later, that is in when I deal with space technology. So, a 10 power minus 10 torr of vacuum, which is very expensive on earth, but we have to produce because we need electronic devices, cell phones, mobiles, etc., on earth. We cannot prepare them on space, though maybe after hundreds of years there may be laboratories on upper atmosphere where you do not require vacuum technology. Vacuum is naturally given in infinite volume. You can have hundreds of laboratories in upper atmosphere without any pumps, etc. Of course, companies who manufacture pumps, etc., they will be in trouble, but you can have lots of manufacturing strategies in the space, but that is scientific fiction. So, what I wanted to tell is, this is a very expensive technology on earth, but it is naturally available in space. So, I want to end this slide with a feel that universe contains 99.9999, how many nines I do not know, percentage of universe is under perfect vacuum conditions. It is only not 1%. You, me, life, water, ocean, planets, all these things exist. I want you to understand this. So, space technology, nuclear technology, electronics, all of them require vacuum because of these conditions. When it comes to the chemistry, up to 200 kilometers is basically same atmosphere with reduced concentrations, it is nitrogen oxygen only. Beyond 200 to 1000 kilometers, it is atomic nitrogen and oxygen. Beyond that, it is helium. Much more altitudes, you will have neutral atomic hydrogen, protons, etc. So, with these things, you get a feel that nature is very powerful. What we are trying to do on earth, so that we will have a better nuclear sector, better space technology sector, better electronic industries, better pharmaceutical industries, chemical industries, lifting industries, transport industries. We are thinking to produce vacuum technology. It is naturally available in billion times this much volume by nature. So, that is called vacuum in nature. With these basic concepts of vacuum in nature and vacuum definitions and units, this class we will end, and we will try to cover the other concepts like history and applications in brief in the coming lectures. Okay. Thank you very much.